Syntax error.
Yeah, correct.
Name error, value error.
No, broad categories. Okay, these errors are one is syntax error, another is exception errors, right? Right, or they are called as logical errors too, right? So, what are the syntax errors? Why do syntax errors occurs?
When we make an error in the syntax of the code,
Yeah,
that time.
correct. So when we do the error in the syntax, then the syntax error will throw. Uh, for example, let's say you did not give the indentation right while writing the code. So for okay, I'll show you the Python documentation which is available on the internet. So from there, I'll try to explain it. Okay. Is it visible for you?
Yes, sir.
Should I do a little zoom? This is fine, right?
Yeah, fine.
Okay, so syntax errors are known as parsing errors, right? And when they will occur when you do mistakes in the writing syntax of a code. For example, here what is the mistake here? While true, print hello world. What is the mistake in this code?
The while loop will not stop.
First of all, it will not occur, right? Because while true, then it should have
Colon, yes.
colon here, and then this print hello world should be on the next line, and indentation should be there, right? So suppose if while true is there, and if I write, so what is happened here? So there is no error in the logic here, but error in syntax here, right? So this error will throw, that is called syntax error, and it will say invalid syntax, correct? Okay. What about exception? Which type of exceptions will occur, and why they will occur? So syntax error, we know that when we do mistake in the syntax, then the syntax errors will occur. When the exception errors will occur? So, if your code is correct syntactically, still what happens is if you do logically, if it is incorrect, right? If your logical statement is incorrect, then it will computer will throw the exceptional error, and there will be certain types of error. So these are the very common errors, right? Zero division error, name error, type error. These errors will throw when you do mistake in logic. For example, so while executing this code, what happened here? 10 into 1 by 0. So why this zero division error came?
Sir, no number can be divided by
By
0.
0. So that in mathematically we know that it is infinity, right? 1 upon 0 something, right? But syntactically it is not correct, right? So that means you are not able to find the answer for this operation. So it will throw zero division error, and which is called as a division by 0, right? Similarly, what happened in the second line here? Name error. So this spam here, it is not defined, right? Correct?
Yes, sir.
Yeah. So and this is called as a name error. So name spam is not defined. That means if you haven't defined a variable or a variable, right, for or and you directly use it inside your code, then this name error will occur. Similarly, type error will occur when the types, right? So you cannot concatenate one string and one integer, right? You can see it from here. So this two is a string, and this two is an integer. So you cannot add a string and a integer, right? So both the types should be same. So either it should be both are strings and both are what, integers. So if they are both are strings, then what will the output? The correct output will be
Two.
2
Two.
right, inside a string. And if it is an integer, then the correct output will be
Four.
4. So this type error will occur when uh, you are the types of the, so whatever you are written inside the code, the type should, if the types are not same, right, then this type error will occur. Okay, now how to handle this error, and why we need this handling exceptions? So why we need the try and except block? So anyway, it is giving you this errors, right? If you do mistakes, the computer will give you the error. But why we need then try and except block?
So that the code won't crash.
Yeah, it
with
should.
executing.
Yeah, it should execute, right? It should not get crash, or it should not get stuck inside a loop, right? Infinite, it should not go on and on without giving any output, right? Or it should not crash. So that's why we are using try and accept block. So okay, you are seeing this code here, right? Okay, so this code is saying what? While true, try x equal to integer input, please enter a number. It will break, and it will, and the except block is except value error. So we are checking for value error, and we'll printing that oops, that was no valid number, try again. So how this try statement works here. So
So this try statement first takes the input, but if there is no input, then it consider it's a value error.
yeah,
And then it prints the accept block, executes the accept block, and prints oops, there is no valid number.
correct. So that means if you see, if you if you have given the number, then that except block will not execute, right? It will try for this statement to be written out, and if it gives the valid output, then that accept block won't execute. You can say in a way, right? But when there is a problem in the try block, then your accept block will execute and it will show you the error. So you can use multiple exceptions here also, right? You can use the multiple exceptions also. How can you do that?
So why putting different classes of errors?
Errors, right? So okay, I think there is okay. I don't know this is taught in the class or not, but yeah, this is what I think it is. Until this point we have learned in the class, right? So this is errors and exceptions. Okay, apart from that, do you have any queries in some other questions? Yeah.
So are we discussing mock questions?
Yeah, today we are going to discuss the mock questions, but Ram will come. Like I'm not going to conduct this session fully. So Ram, I think he'll join after like 15-20 minutes. Like maybe he'll join around 2:25 or something. So he will take the mock questions from there. Okay.
Okay, sir. So
So
can we discuss list comprehension until Ram sir is coming?
okay, list comprehensions we can discuss. Yeah. So,
Hello, sir.
yeah.
Which time it will be given value error?
What?
I didn't get it. Value error
Value
we
error.
discussed.
Yeah.
Which time it will be given? I joined late. That's
No, we were discussing the this try and except block, how to handle the exceptions. We are discussing that. So there will be broadly two types of errors, right? One is syntax error and another one is exception errors, we call it. So syntax errors will occur when you have syntax incorrect, right? Syntax for the
yes.
code incorrect. And exception errors will occur when we have some sorry, logical errors. For example, this question, right? If you see 10 into 1 by 0, so you cannot divide any number by 0, right? So the computer will
Yes.
throw a zero division error. Or sometimes if you
Yes.
do not define a variable previously and you use that variable inside this, right? So this it will show name error, that is name spam is not defined. So that like we have number of errors like this, right? Here this code is
Yes.
wrong or not? This code is correct, right? 10 into
Yes.
1
Code is
correct. This
yes.
4 plus spam into 3 is correct. So syntax wise it is correct, but it is having the logical error. That means you haven't defined something properly, or you did the division by 0 which is not uh, accepted in the Python programs, right? So that's why it will
Okay.
throw some errors, and we'll handle those errors by using this try and except block. That's what we are discussing. Okay.
But I got value error. I didn't got value error. So I got zero division error, syntax error, or
So
name
what
errors.
will happen if what will happen here if you, so if you do not, so what is this code? X equal to integer input, please enter a number, right? That means
Yes.
user input should be needed. So if you do not give any input, and if you just place click on the enter button, what will happen? It will throw an value error, right? Without,
Okay.
so that means you haven't provided a value, right?
Okay. Okay. Got it, sir. Thanks.
So list comprehension, I think. Can you have anything? Okay. So shall we discuss some problems in list comprehensions or what?
Yesterday also sir discussed, I think, sir. So can we do mock?
Okay. So if that is discussed already, okay. 1 minute. I'll just mock test. Actually, I'm waiting for Ram to join. He'll take the sessions through ahead. But okay, let's see something. So okay, this is the question, right? Mock test center.
Yes, sir.
Okay, so first question is a graph G can be defined as an ordered set G with V and E, where V represents the set of vertices and E represents the set of edges. So which are the vertices in this graph?
Numbers are vertices and the
Vertices,
lines joining them are
Number.
edges.
edges, right? So 1, 2, 3, 4, 5, 6, 7, 8 are the vertices, and the lines joining these numbers, these are the edges, right? Okay, so it is also mentioned here, right? Vertices are 1, 2, 3, 4. So it is a set of these numbers, and edges is a set of these numbers. So every possible combination, right? That is 1 and 2 are joined, 2 and 8 is joined, 2 and 3 joined, 2, 6 is joined, like that 3, 6, 3, 4, 4, 6, and 5, 6, and 3, 7, right? 3, 7 here, right? Okay, so this is an undirected graph, right? Okay, that is okay. So what is G? G is a dictionary which is equal to vertex and list of adjacent vertices. So what is if one is my vertex, then what is the adjacent vertex to it? So it is a list, right? So only two is there, only one. For two, it will be 1, 3, 6, and 8, correct? A list of 1, 3, 6. So this dictionary, you understand, right? So these keys are all vertices, and values are the list of those vertices which are adjacent to these values, right? Okay. Okay, so this is a given. So define f of this function is defined graph and vertex. Return length of the graph of vertex. Okay, define G. Okay, so shall we see the question first? So question 1 is degree of vertex V. It is a number of adjacent vertices. So you guys have already solved this question mock paper, right?
Yes, sir.
Yes.
Okay. So question 1 is degree of vertex V. It is a number of adjacent vertices to a vertex V. Okay. So function f graph vertex returns degree of vertices in graph. So is it true or not?
Yes, sir.
Function f
True.
is graph and vertex. It returns length of the graph of
Uh,
vertex, right? So
Values.
it is taking what?
So it's taking values against key, len of values, and which is like number of edges.
Number of edges. So it returns the degree of vertex, right?
Yes.
Okay. Can you tell me what is degree of vertex?
So the number of edges that comes out from a vertex.
Number of edges that can be comes out of the vertex. That means for this vertex 2, what will be the degree?
4.
4, right? That means number of edges or number of adjacent vertices, right? So
Yes.
the length of the list, right? Everybody understood this, right? This one, right?
Yes, sir.
Yes, sir.
Okay. Okay. What about the second question? For above graph G, what function G of G will return? So G is a function.
Length of
8.
Length of the graph.
graphs. 8.
8, sir.
It will take
Number of keys it's
keys.
asking.
It it is take what function you it will return the number of values, right? or
Yes.
number this 1, 2, 3, 4, 5.
Number of
Number of
Yes.
vertexes.
Vertexes.
Number of vertices. So it is the length of that this set V, right? Actually, it will take so length of this set, correct? So it will return the number of vertices. So what will be the correct answer to this? It should be 8. Okay. What does this function h returns? Function h returns number of edges or graph. It is true or not? Okay. What is
Yes, sir.
function h? Function h takes graph t equal to 0 for v in graph t plus length of graph v. Okay, return t by 2. Okay, what will it return? This
Is that average of the length of vertexes?
Yes, length of vertex.
length of vertices.
Not
Okay, so does it give number of edges in a graph?
Yes.
It will give number
yes,
of
number of edges. Yes,
it will give
No.
it's
okay, number of edges are what? Tell me number of which are
The value of
Numbers-
the vertex.
value of the vertex, right?
yes. It will be gives total value.
What is h of okay? How you will input this? So h of graph, that means you are in and when t equal to 0 for v in graph. So what is graph here? Which set?
Graph is
A
that
dictionary.
is dictionary.
It is a dictionary, right? And in dictionary it is checking for vertices, right? V.
Graph of one. Graph of
Yes,
It is a pair of what?
it will take vertex, return the length of vertex.
So it will
Adding, not returning.
and it will return t double. So it generally what will so for example, if it takes which thing it will take in this dictionary. So in this graph G, it will take which one? This two or this list?
value as t.
Length of the list, I guess.
Length of the list, right?
Yes. sir.
Right?
Yes, sir.
And what it will do? It will add to t. It will divide it by 2. So it will give edges or not then?
No, no,
Yes,
no,
Yes or no?
no,
Yes,
sir.
sir.
yes.
No, sir, no.
No, sir.
Okay, why no and why yes? First of all, why yes?
Because we are adding edges.
We are adding edges
We are
also.
adding edges.
And then you are
Yes.
dividing and then you are dividing it by 2 also.
Dividing by 12. Yes.
So
When
then
you are dividing, we are
Because
yes. When you are dividing, we are
each
just
vertex
stopping.
is connected to two edges, so we have to divide it by 2.
each edge is connected to
Connected to each vertex is connected to
Sir,
two
it's
edges, so that we have to
Sir,
divide
it
it
is
by 2.
actually an undirected graph.
undirected.
Yes.
Yes, sir. So actually, we are calculating edges twice. Since if it would have been an undirected, directed graph, then we would have been dividing it by 0. But since we are calculating our undirected graph, t would be counting the edges twice. So we will be dividing by 2, so we will get the edges.
Right. Anyone who said no, it's whatever the explanation given by. Okay, sorry. What was your name?
Sir, my
Manan. Okay.
Manan,
The
sir.
explanation given by Manan is correct, or do you have any other answer? Who said this? These are not the ages.
Sir, I couldn't understand that explanation, but according to this function h, I just added length of all the lists that are given in the dictionary, and it's 18, and 18 by 2 is 9, but number of vertices are 8, so it's false.
Okay, according to you, what happened? Sorry, Manan, you want to say something here?
No, sir.
No, what she did is, she has counted this number of list, and she has right, Parul?
Yes, the length of the list, and I summed it up. and it's 18, and 18 by 2 is 9. And the
Hmm.
number of vertices are 8, so it's false.
And okay, how many number of edges are there?
It's a 9.
Oh, I'm sorry, I just counted the vertices.
Correct, right?
Yeah,
So it is giving what number of
edges, yeah.
edges? So it is correct, right?
Yeah.
Correct. So the answer should be true, right? True, it returns the number
Yes.
of edges. Okay. Okay. Now the fourth question is, a regular graph is a graph in which all vertex has an equal degree or an equal number of the adjacent vertices, right? So okay, you guys have studied this, right? Graph theory and everything in
Yes.
Yes, sir.
in
Yeah,
Python or in
Math
CT?
one.
Yes, sir. In
in
maths
city.
one.
In CT, okay, or in Vic 12?
No, sir.
Only in CT.
Math one.
Okay.
Yes, sir. This was in maths one.
Right. Okay. Fine.
Math 1 as well as city.
Okay. Fine. So you are you know all this stuff, right? That's what I wanted to say. Okay. Fine. Okay. A regular graph is a graph in which all vertex has an equal degree or an equal number of the adjacent vertices. So which of the following code is correct to fill in the function regular graph to check graph is regular or not? So regular graph is what? So equal number of so every vertex has equal number of adjacent vertices. If it is having, then it is called as a regular graph. Correct? So okay, what will this okay, which of the following options is correct? First of all, tell me that.
Last one.
Okay, option D, someone is saying. Any other option?
Sir, C.
Option C. Okay. Any other? Option C and D. Okay. So we have to check. Okay.
Option C, sir.
Okay.
Sir, could you scroll down? I see. Not option C, D, sir. Option C, I think. I forget.
Okay.
That is
Option
not equals to. It must be not equals to.
it must be an article. Okay. So you are unanimously you are saying that option C is correct, right? Not option
Not
D.
option. Earlier I said
Sir,
option D.
option C.
Yes.
Yeah.
But
So
I forget. I
okay.
forget the actual numbers.
So you are
That's
saying
why.
that option C is correct, right? Everyone is okay with?
Yes.
Yes, sir.
Okay. What will happen in this code? So shall we check the code whether it is correct or not? So
Yes.
Yes, sir.
Okay.
okay. So that there is a flag, right? So reg equal to true, then degree equal to 0. For v in graph, if degree equal to 0, then degree will be equal to f of graph and v. So this is related to our first function, right? Previous I think this is okay. All 5 questions are related to this. Okay, and I think it is directed to this functions. So okay, so okay, what does this option C will do? So for v in graph, degree equal to 0, degree equal to f of graph v. What does this function will give the output?
First of all, we are taking one the vertex. We are checking. We are counting that degree. Then we are taking another vertex, checking this degree equals to the previous degree. If it is true, then it will do nothing. Or if it is false, then it will be break from the loop.
Correct. So just a minute. I think Ram is going to join in a few minutes. Just a minute. I'll let him join and we'll discuss that.
Here I am unable to understand the difference between code 2 and code 3 break.
So, Mayur, are you there?
Yes, Ram. Yeah.
Yeah. Okay.
So, yeah, I will leave now and you can continue.
Yeah. First, like screen sharing is allowed for everyone, right?
Yes.
Okay. So thanks, Mayur.
Yeah.
Yeah, I'll continue the session now.
So, Ram, we are in the mock test question number 4. So you can continue from there.
Okay, sure. Are you able to see my screen?
Yes, sir.
Okay. So what do you want me to? Okay, can directly go to the question number 4, right? So they are saying that a regular graph is a graph in which all the vertex has an equal degree or equal number of adjacent vertices. Which of the following code is correct to fill the function regular graph to check it is a regular graph or not? Okay. So initially, okay, we have this regular function, regular graph one. Okay, graph comma vertex, f of graph comma vertex, it gives you the length of graph of vertex. It gives you the f of this one, f of graph comma vertex. It gives you the number of vertices it has, right? I mean,
total number of degree to that vertex,
yeah,
right?
Yeah, the total number of degree. So we can use that f1, okay, to solve for this. Initially, we will be assuming that it is a regular graph. Okay, so they just given that, and then degree equals 0. They mention for v in graph, if degree equals 0, they mention degree equals to f of degree equals f of graph comma b. Okay, then else if degree not equals to f of graph comma b, then they mention regular equals to false and then break. Okay, this regular equals to false one, that is okay, because if degree is not equals to f of graph comma b, then this should be, then origin should be made as false. Okay, but then in the else part it should not be break. Okay, it should not be breaking. We should not be breaking out of it if it is, I mean, if you are breaking in the if you are breaking in the else part, which means that if degree equals to f of graph comma b, then we are breaking out of it. Okay, that is not true. Okay, we should be checking for each and every other vertex too. Okay, so the first code is not correct. Okay, in the second code, we are seeing that if degree equals 0, we mentioned dg equals to f of graph comma b, that is okay. If degree is not equals to f of graph comma b, then we have this regular equals to false. Until there it is correct, but then this break part is not correct, because this break should be there within the if block. Okay, I mean, once we encounter the false, right? Once we encountered reg regular equals to false, then only we should be breaking out of the loop. Right now, what is happening is, irrespective of whether this degree is not equal to graph comma v or not, then it's going to break out. Okay, so that is why the code number 2, it's false. I mean,
Could you please explain what actually break is doing here?
Okay, so for example, let's say we have here, we have let's say 5 vertices. Okay, 5 vertices. So for the first vertex, what's going to happen is, for the first vertex, initially dg is going to be equal to 0, right? So the if block will not be getting executed. Sorry, the if block will get executed. dg equals 0, so dg will be made as f of graph comma b. Okay, f of graph comma b. Okay, and then you will not be entering the else block. Okay, you will not be entering the else block, but for the second vertex,
Is the first if block is assigning the degree of the first one, or
yeah, it's assigning the degree of the first one only.
okay, sir.
I mean, degree of the first vertex we are assigning that to dg. Okay, and let's say now that we are in second iteration. Okay, second iteration or second vertex. Okay, now since we have already assigned dg to f of graph comma b, DG will not be equal 0. So the first, I mean, we will not be entering the if block. We'll enter the else block. Okay. Once we enter the else block, if DG is not equal to f of graph comma v, then we will assign REG as false, and then we'll break. Okay. But then let's say if DG equals f of graph comma v, then we will not be assigning REG equals false, but still we'll be breaking. Okay. But still we'll be breaking. So
this means here because of this break, regular equals to false won't execute.
No, regular equals false will get executed. Regular equals false will get executed if degree is not equal to f of graph comma v. What I'm trying to say is, it doesn't matter whether this if block is getting executed or not, but the break will always get executed. Okay, in the second iteration.
That means this break is for else. Whenever it enters into the else loop, it will break.
Yeah. It's automatically going to break, and then which means it's going to come out of the for loop. Okay, in the second iteration.
It means it's not related to the if block. Whatever is there in the if, it won't consider.
Yeah. So that's what I was trying to say. Doesn't matter what happens in the if block. That is whether this DG equals to f of graph comma b or not. So the break is always going to get executed. But that's
I have one more doubt. When this break is in line with else, these both are same?
When this break is in line with else, which else part?
Second code else. Second. This one.
Right?
Yeah. If break is in line with the else, in straight line with the else.
It is already in line with the else part, right?
No. If I keep break in straight line with else, with E, else E is there, right? Else E, first E.
Okay, wait, else first E. Okay, here.
No, first E, left side. In line with if, else break. If three are in line.
Okay, inside with if degree is not equal to f of graph comma v, you're saying that you'll break. That's it? That's what you're trying to say?
No, in straight line, far is there, na? That is one straight line, right?
For V graph, that this part.
Okay, next, if condition is there, right? If I draw a straight line for I, E, and then break, I will keep. Vertical line.
Sir, you want to decrease the intention of the break.
Yes, I want to
just below else.
Okay, she wants to decrease the indentation of break. She wants it to be here, is it?
Yes.
No. Still it's going to be wrong.
Now, what is the difference between the break? These two positions.
So if the break indentation is like, if you're reducing the break indentation, then the break corresponding, I mean, it doesn't matter what happens in the if else block, then the break will get executed in the first iteration itself. Okay, am I making sense? Okay.
Yes. After else or before else?
Sir.
Yeah, after. Okay. So
but after if it's executing, right?
Yeah, let me write
the first iteration. After the first iteration.
Let me write the code for it. Okay. Let me show it in a different way. So we have here. Are you able to see my screen?
Yes.
So let's say we have this define regular, and then we have graph, right? This is the one. For V in graph, initially we should be having this origin equals to.
You can take any simple example also. Then you need to copy the graph here to execute this.
Okay, but
work.
DG equals to 0. Okay, for V in graph, I will check if DG equals 0 or not. Okay, if DG equals 0 or not, and then if DG equals 0, then I will be assuming I will assign DG to f of graph comma V, right?
Can we try break here itself? Three indentations.
We could try break here also, but then that's not the correct way, right?
And that is okay. Just to check the break indentations, three positions I want to know.
Yeah. You could have the break anywhere actually. Could have the break here also. Okay. Fine. So you could see, right? Once I mentioned break there, this one dull color. This one dull color, right? What it's saying is basically this will not get executed. Once you enter the loop itself, you'll get break.
Yes.
Okay. So right now, let's say after this break statement, let's say I enter some line say equals to something like 100 or something. Okay, you could see even this a equals to 101 became dull. Okay, VS Code is saying that since you already entered the break part, the line below it did not get executed. Okay, but let's say we were in the else part. Okay, we are in the else part. Then we will check if degree equals to f of graph comma v. Okay, if this degree is equals to f of graph comma v, then okay. If it is equal, then we need not do anything. If it is not equal, then we should change the regular to false, right? Okay, we should change the regular to false. Ideally, we should be breaking out of the loop here itself. Okay, because once we encounter this condition, okay, once we encounter this condition of like false, there itself we should be breaking out of the loop. Okay, but the second option what it mentioned is it mentioned something like this. Okay, we are not breaking inside the if block, we are breaking outside the if block. Okay, is this clear what I'm trying to say?
Yeah, fine, but I'm unable to understand. Could you please back tab break? Back tab. Yeah. What is the difference between this break and the second indentation? That's I'm unable to understand.
Okay, so here the break will get executed once it enters the else block only.
Okay.
If you are like unintended this, then here the break will get executed irrespective of whether it enters the if else block or not. So which basically means the break will get executed in the first iteration itself. Okay.
Will it enter into the first if? No.
First, like it might enter into the first if, or it might not enter, or it might not enter. Okay. Let's say I remove this break one. Okay. I'll remove the break one. Okay. So it might enter if block, or it might enter else block, but doesn't matter. It will always, I mean, it will always execute the break part. So
after in the first iteration,
yeah, after the first iteration, we'll be doing the break. Okay.
Okay.
Which we do not want, right? We should be checking for all the verses. Okay. So ideally, this should be the position where the break should be. Okay.
Okay, clear for me.
Yeah. So that is the reason why the second option is strong, and then third option is correct. Okay. Whenever we encounter the false, we should be breaking out of the loop. Here, when it is equal, we should not be breaking out of the loop in the fourth option. When it is not equal only, we should be breaking out of the loop. Okay. Clear?
Yes, clear.
Yes, sir. Clear.
Okay. Now we'll move on to the fifth question. You have a complete graph is a graph in which every vertex connects to the remaining vertex by a direct edge. So if a graph has n vertices, then degree of vertex should be n minus 1. Okay, for it to be a complete graph. Okay. Which of the following code is correct to fill the complete graph to check graph whether it's complete or not? Okay. Here it's exactly similar to the previous question. Okay, except for checking that checking whether we have each degree is equal. I mean each vertex degree is equal or not. We should now check whether each vertex degree is n minus 1 or not. Okay. Clear? Is this clear? Is question clear first of all?
No.
No?
Yes, sir.
Okay, let's say we have like n vertices, okay? They're saying that it should be connected by a direct edge, which means that the degree of each vertex should be n minus 1 for it to be a complete graph. So all the vertices should be having same degree, and the degree also should be equal to complete graph. I mean, sorry, n minus 1 for it to be a complete graph. Okay. For each vertex,
okay,
the should be equals to n minus 1. Then only it will be a complete graph. Okay. Clear?
Oh, okay, okay.
Okay. Now we'll be assuming similarly, we'll be assuming complete equals to 2 and then degree equals 0 initially. For V graph, if initially degree will be equal to 0, right? So we'll assign degree to f of graph comma v. Okay. F of graph comma v. If degree is not equals to length of graph minus 1, then we should not be making comp to true. We should be making that complete to false. So the first option is wrong. Okay. The second option, if we'll check for this, if degree is not equals to length of graph minus 1, then we should be assigning complete to false and then break. That is correct. In the else part, if degree is not equals to f of graph comma b, then we should assign complete to false and then break. Correct. So this one is correct. The second option is correct. Because whenever, okay, the second option is not entirely correct. Yeah, no, it's correct. Because in the first line itself, in the first iteration, like when degree equals 0, okay, when degree equals 0, we'll assign degree to for the first vertex degree, okay, and then we'll check whether the degree is equals to length of graph minus 1 or not. If it is not equal, then we'll break there itself. If you're not breaking here, it means that degree equals to length of n minus 1. Okay. Now when we are checking in the else block for the next iteration, if degree is not equal to f of graph comma b, indirectly we are checking for length of graph minus 1 is not equal to f of graph comma b or not. Okay, because degree is going to be equal to length of graph minus 1. If it did not break. Is this clear what I was trying to say? No? Yes?
Yes, sir.
Okay. Is this clear for everyone?
Yes,
Here,
sir.
Sir, why are we doing len of graph minus 1, sir? I couldn't understand.
can you repeat?
Len of graph minus 1, that part.
Why are we checking for that?
Yes.
That's your question. Why are you checking for that? Here they mention that for a graph to be complete, right? The degree of each vertex should be n minus 1.
Okay.
So that is why we are checking whether it is equal to n minus 1 or not. If it is not equal, then we should change the compute to false and then break, right?
Okay, sir. Thank you.
Yeah. The third option, we are having this computed to false, right? Complete to false. Even the third option, in the third option, we are not breaking here itself. Okay, I mean, in the third option, there are like two mistakes. One, we are not breaking. One, we are checking whether the degree is not equal to length of graph minus 1. Okay, we are checking it equals to length of graph. It should be length of graph minus 1. Okay, and also we should be breaking out of it whenever we encounter this complete to false. Okay, that's why third option is not correct. And then in the last option, the problem is that whenever we encounter this false one, we should be breaking out of the for loop. Okay, so here it should happen ideally if degree is equals to length of graph minus 1, it should happen in degree is not equals to length of graph minus 1. Okay, here it should happen degree is not equals to length of graph minus 1. Okay, that is why the fourth option is wrong. All right, this is clear.
Yes, sir.
Okay. Now we look at the question number 6. Suppose L is a list of integers that is already initialized, which basically means L is some list which is already defined. Okay. Define P of L A equal to 0 for I in range of. Okay. They have mentioned some functions. What P of L returns after the execution of above code. Okay. P of L equals A equals 0 for I in range of len of L. If L of I is not in L of the previous, A plus equals to 1. Return A. Yeah, Mananjan, you are raised your hand.
Sir, I wanted to say that when we were practicing mock, these questions were fairly easy, but there were some questions that were difficult. So can we look to them? Because these were easy.
We'll discuss the entire questions. It's not like we'll discuss only a few particular questions, right? We'll discuss all the questions. Okay. So
okay, sir.
We'll discuss all questions. We'll discuss easy too, and then as the hard questions as I mentioned. Just like we discussed the object-oriented programming yesterday, which you found difficult. Okay.
Yes, sir. Thank you, sir.
So we have here for I in range of len of L, if L of I is not in the L of this, what does this mean? Can someone tell?
First to last.
Not first
Last
to
one.
last. First
Last
to the
one of
ith element.
Ith position.
Like
Till I. First to
Yeah.
till I.
yeah, first to till I without including I, right?
I minus 1 position.
Yeah. First I minus 1 elements. Okay, correct. So what does that say? I mean, okay, now that we know what this means, can someone tell me what this entire code block means?
It will check the number of elements.
Distinct elements.
Yes, exactly. So how does it check for the distinct elements? If it is checking whether that element L of I is already present in the previous I minus 1 elements or not. Okay. If it is
Yes.
already present, then it will not count. If it is not present, only then it will count. What does that mean? We are checking for the distinct, right?
Yes.
Okay.
We're excluding repetition.
Yeah, we are excluding repetition. So P of L is going to count the distinct elements in list L. Okay. So it's not going to count total number of elements. That's not correct. Total number of elements that are repeated. No, not that. That is not correct. Total number of distinct elements. Yeah, that is correct. Okay. Clear? The P of L. Okay.
Yes, sir.
Now we'll go for this Q of L. B equals 0 for I in range of.
Sir.
Yeah.
Previous code, when we are given list of 1, 2, 3, first iteration, it will be the one. And
List of 1, 2, 3 in the first iteration. Yeah, it will be 1.
One, it will be checking list of 1 in present or not. It will be 0 to 1. 0 to means that will be present 0 1. It not count.
I'm sorry, your voice is breaking. So you're saying that for a list of like 1, 2, 3, it has 3 elements.
Yes.
1, 2, 3, right? That's your problem, right? That's your list L, right?
Yes.
So yeah.
Yes.
I'll tell you what
iteration.
Yeah, in the first iteration, it's going to check for L of 0 is there in L of until 0, which basically means in the initial it's going to empty list. Okay. So obviously it's going to by 1.
Sir, yes, it is list.
Okay. In the second iteration.
Okay, that is my fault.
It's going yeah. Is it out clear?
Got it. Yes, got it. Got it, sir.
Yes. Okay. Now you look at
counting 0 to 1, empty to 0.
Yeah. So now we'll go for this Q function. Okay. For I in range of len of L, it's not checking for if L of I not in L of I. It's checking if L of I is there in the previous elements. Okay. Previous elements of the list. It should be there, and it should not be there in the next I plus. I mean, from the I plus 1 index to the later elements, it should not be there. What does that mean? Can someone tell me?
After noticing the ith element in the L, after that it should not be there, the ith element, right?
Yeah. So basically, it should be there like in the previous set, but it should not be there in the next set. I mean, the next slicing part. Okay. So then we'll be incrementing it. So basically, here we are counting for the repeated one, right? Correct? Am I right?
Yes, sir. Yes, sir.
So
but if second is not is there, then also same count, right? If not is there in second if.
Yeah, if it should not be there in the next set, only then we'll be counting it. Okay, I'll tell you one example. So for example, let's say I have this define view of, there is a reason why they have mentioned that second one, it should not be there in the next set. Okay, initially A equals 0 for element.
But the answer is the element repeated more than one time.
Yeah. It should be repeated more than one time. That is evident, right? No?
Yes, that is fine. But why the second if?
Yeah,
what is the
I'll
purpose
explain.
of giving second if?
I'll explain that. Okay.
Sir?
I'm writing the code for that only. Are you able to see my screen?
Yes, yes.
Yes, code. Okay, if L of I is there in the, it should be there in the previous set. Okay, then we should check for the L of I is not there in the next set.
Sir,
Yeah.
sir, can you take a list as an example?
Yeah. I will
Like-
take a list as example and then I will explain. Okay. So let's say my L is equals to 1, 2, 2, 2, 1, 1. Okay. So for example, let's say I do not have this. I mean, we'll do two scenarios. First having line number 7 and next one without having line number 7. Okay. Fine.
Okay, fine.
So first in the first iteration, obviously L of I is not going to be there in L of I is not going to be there in L of 0 is not going to be there in this empty list. Okay.
Right.
Correct. So this basically means empty list. Okay. This means empty list. Okay.
Yes.
So initially L of 0 will not be there in the any element. So it will not enter this row. Okay. Correct.
Yes.
So, and in the second iteration we have here L of 1 is going to be 2. Okay. And then this is going to be equals to
1.
This is going to be equals to 1. Okay. And 2 is not there in this list, so it will not enter this if block. Okay.
Okay, sir.
In the third iteration, we'll have here this until 2, right? It's going to be 1, 2.
Yes.
Okay. Now
It will
2 is there in this. 2 is there in the in this list, right? In this 1, 2 list. So it will enter the if block, and then it will check whether this 2 is there in the remaining elements of the list, which basically means what are the remaining elements?
2, 2, 1, 1.
Is it like 2, 2, 1, 1 or 2, 1, 1? Because we are going for I plus 1 to remaining. Okay. L of I is 2, right? L of I is 2, right? Yeah.
2, 1, 1.
2, 1, 1, correct. So now 2 is there in the 2, 1, 1. Okay. So we will not increment the count until now. Okay. Clear?
Yes, sir, clear.
Yes.
So now we'll go to the next iteration. That is this 2. Okay. Okay. Now
sir.
here the list is going to be 1, 2, 2. Okay. 2 is going to be there in 1, 2, 2. So this if block is correct. I mean this if condition is correct. Now if 2 is not there in the remaining ones, now it's going to be 1, 1, right? 2 is not there in it. Now we'll increment now we'll increment this a by 1. Okay.
Yes.
Clear?
Yes.
Now let me. Okay. For simplicity purpose, let me just have it like this way. Okay. Okay. Let me just continue. Let's not make it like complicated. Okay. We have here 1, 1, 3, right? Okay. Now, this 3 also. Okay. Now let me go for the next iteration. Now this L of I is going to be equals to 1, right? Okay.
Yes.
Now this is going to be equals to 1, 2, 2. Okay. Now 1 is there in the 1, 2, 2, right? So it will enter the if block. Okay. But L of I is not in the L of I plus 1, 2. What is this be? This is going to be equals to this I, right? Okay. This one, right? So 1 is there in this, 1 is there in this. So it will not enter the if block. Okay. So A will not be incremented. Okay. In the last iteration, we'll be having these two L of 0 to 1, 2, 3, 4, 5. Is this the one? Correct? or is it like 4? 0, 1, 2, 3. Yeah, it's going to be 5.
5.
And then now it's
That
going to
means
be,
it's counting exactly one time, right? Not more than one time.
yeah. We should just be counting the number of repetitive elements. We should just count the number of repetitive elements. Okay. We should not be counting the number of times it got repeated. Okay. Here 2 got repeated and 1 got repeated. Okay. But then if you do not have this, what's going to happen is you are going to encounter, I mean, you are going to increment this by more times than you want. Okay.
No, here we are counting the element that repeated exactly one time.
No. We are not counting the element that got repeated one time. Okay. At the end of this iteration, at the end of the second, I mean, last iteration too, what will the value of A be? It's going to be 2, right? Am I right? It's going to be 2, correct? Correct now? 1 is going to be there in this set. Okay. 1 is going to be there in this set, and L of I is not going to be there in this empty set. I mean, empty list. Okay. So we will increment the A by 1. Okay. Now initially A is equals to 1. Now A got increased to 2. And then we are returning 2. Okay. We are returning 2 because we once we return because of 1, and in the second time in the first instance we incremented because of 2, and in second instance we incremented because of 1. Okay. You are saying that we are just counting the number of elements that got repeated twice, right? But 2 got repeated thrice, 1 got repeated thrice. We are just counting the number of repeated elements. Number of elements that got repeated. That's it. It doesn't matter how many times it got repeated. I just need to count it once. Okay. Just to make sure that I count it once, I'm having this block. Okay. Is this clear?
Yes, sir.
Suppose if I do not have this, one, right? Then you're going to count it like more times. Okay. You're going to count it like nearly 4. It's going to be equals to 4. Okay. Let me run this. Print Q of L. Okay. Okay. Okay, it gave me 4. Okay, but then the number of elements that got repeated is only 2, right? 1 is there and then 2 is there. We don't even have 4 elements, 4 distinct elements. But let's say I have this block. If L of I is not in I plus 1 to the remaining one. Okay. Now if I run this, the answer is going to be 2. Okay. I'm just counting the number of elements that got repeated. Okay.
Okay, sir. Get it.
So for Q, right? We're going to count.
Do we expect these type of questions also in editor?
What?
Do we expect this type of simple questions also in editor?
Yeah. You can expect this type of simple questions, but these are not entirely simple, because you could see that it is still tricky. Okay. Total number of elements that are repeated in the list more than one time. That's what we are counting. Okay. Second largest element we are not counting. Now we'll go for this one, R of L. Okay, R of L. Okay, X equals 0, Y equals C equals 0 for I in range of len of L. Okay, in range of len of L, we are having, if L of I is not in the previous elements. Okay, then we'll have Y equals to 1. else means that L of I is there in the previous elements. Okay. And then we have L of I is not equals to L of I minus 1. Then we have y equals to 1, which basically means it is not equals to the previous element. Okay. Then we'll make y equals to 1. Else we will increment if it is equal to the y, if it is equal to the previous element, right? Only if it is equal to previous element, then only we will enter the else block. Okay. Then we will increment y by 1. Okay. And if y is greater than d, we'll make z equals to L of y and then d equals to y. Okay. Oh, sorry. I entered S. I should be reading R. Sorry. For I in range of len of L, if L of I is greater than C, then we'll have x equals to C and then C equals to L of I is greater than C. Then we'll have x equals to C and then C equals to L of I. Else if L of I is greater than X, we'll make x equals to L of I and then we'll return X. What does this mean? Can someone tell? This R1?
Second largest.
Sir, it calculates the largest and second largest element of a given list and returns the second largest element.
Exactly. Okay. And how do you know that it is calculating the largest and second largest? First thing here, if L of I is greater than C, okay, if L of I is greater than C, then we are equating X to C. Okay, what this basically means is whenever you are encountering the largest element, okay, largest element, up until that point, you are storing the largest element in C, but then the previous largest element up until then, which is C, that you are equating it to X. Okay. So X stores the second largest element and C stores the largest element. Okay. We have written here else block because even though L of I is not greater than C, which basically means L of I is not the greatest element, it could be the L of I could be the second greatest element, which means L of I could be greater than X. So that is why we need to write this else block also. Okay. So R stores the second largest element in the list here. Okay. Is this clear? Problem number 8, is it clear?
Yes, sir.
Okay. Now we'll come to the toughest problem here. S. Okay. Initially D equals 0 for I in range of len of L. If L of I is not there in the previous set, right? Okay, then we'll have I equals to 1. Else, if you are entering else, it basically means L of I is there in the previous I minus 1 elements. Okay. Now we have this L of I is not equals to L of I minus 1. Then we'll have y equals to 1, right? Which basically means it is not equals to the previous element. Correct? Let's say I have L of 0 and L of 1. I am at L of 1. Okay. If L of 1 is not equal to L of 0, then I'll have y equals to 1. Okay. Else I'll have y plus equals to 1. The reason we enter else is if L of I is equals to L of I minus 1, then we are incrementing y by 1. Okay. Now we are checking if y is greater than d. If y is greater than d, then we are updating z to L of y and then d to y. What is this doing? Can someone tell me? It is
Sir,
counting
this
the
particular part of code, it equates the value of z equals to the value of that element, which is getting repeated multiple number of times, and the value of d is equals to the number of times the value is repeated.
It's not just the repeated one, it should be repeating continuously, consecutively. Okay. So because see we are not just checking for the length of the L of I. Okay, the count of L of I we are not checking. We are just checking for the L of I is not equals to L of I minus 1 or not. If it is equals to I minus 1, then we are incrementing it by 1. Okay, which basically means we are checking for the consecutive elements. I mean, consecutive elements we are checking. Okay.
Okay, sir.
So this S of L, it returns the first element which is consecutively repeated more than one time. No, it checks for the first element which is consecutively repeated maximum number of times. Correct. Okay. First element which is consecutively repeated, last element no, because this last element and first element, how do you know this? If y is greater than or equal to d, okay, if y is greater than or equal to d, then you will be having the largest element which is repeated like largest number of times. Okay, last element that is repeated largest number of times. If it is y greater than d, then it will be the first element which is consecutively repeated maximum number of times. Okay, I'll show you an example for this. For example, let's say my list is okay. Let's take this list itself. Okay, I have 1 comma 1 comma 2 comma 2 comma 2 and then 1 comma 1 comma 3 comma 3 comma 2. Okay, something like this. Okay, here 2 got repeated 3 times consecutively, 1 got repeated 3 times consecutively, and then 3 got repeated 3 times consecutively. But the output of this code will be equal to 2 only. Okay, because after this I equals to 3, right, I'll have d equals to 3. Okay, because 2 got repeated 3 times. Okay, after this iteration, I'll have this y equals to 3, and y is not greater than d, right? 3 is not greater than 3, so the z value won't get updated to 1. Okay, even here also it's the same scenario. Okay, this is clear what
Yes,
I'm
sir.
trying to talk about.
Yes, sir. This is now clear.
Okay, but for example, let's say they have written y is greater than or equal to d, y is greater than or equal to d, then it would have been 3. Okay, because even though it is equal, they mentioned equal to, right? Even if it is equal, we'll be updating the z value. Okay, clear?
Yes, sir.
Now we'll move to question number 10. Which of the following options can be used to produce a first n Fibonacci numbers starting from 0? Okay, this is the series which they mentioned 0, 1, 1, 2, 3. Okay. Which basically means the first two Fibonacci numbers are 0, 1. Okay, what is a Fibonacci series? Can someone tell me? What is a
Sir,
Fibonacci series?
Fibonacci series. Sir, Fibonacci series is a series in which the last number is the output of last two preceding numbers. So if we have the third element, then it will be the sum of first and second element.
Yeah, exactly. So Fibonacci series is a series where nth element will be equals to the previous sum of the previous two elements, which is nothing but nth element is going to be n minus 1th element plus n minus 2th element. Okay. Here you could see, for example, I have here 5, right? I got 5 because 2 plus 3 equals to 5. I got 8 because 5 plus 3 equals to 8. Similarly, 13 is because 5 plus 8 equals 13. Okay. Clear?
Yes, sir.
Fibonacci series is clear, right?
Yes, sir.
Now we look at this one which produces the first n Fibonacci numbers. Define Fib of n, a comma b equals 0, 1. Find range of 0 to n, a comma b equals to b comma a plus b. Return a.
Yes, A is correct.
Produces the find range of n. Print Fib of 5. Okay. So for example, let's say we have 0. Okay.
It will be 0.
Fib of 0 is going to be 0, correct? Fib of 1 is going to be a comma b equals
1.
to b comma a plus b. Yeah. Fib of 1 is going to be 1. Fib of 2 is going to be a comma b equals 0, 1. Find range of 0 to 2. 0 to 2. So it's going to run for 2 times. Okay. A comma b equals to b comma a plus b, right? So it's going to be 1 comma 1 plus 0, 1 comma 1. Okay, it's going to run again. Okay, now a comma b is going to be equals to b comma a plus b, which is going to be 1 comma 2. Okay, and it's going to return a, which is going to be 1. So fib of 2 is also equals to 1, which is correct. Okay, in the similar way, it's going to return like for the n terms. Okay, since we are running the loop for like n times, okay, it's going to produce the first n Fibonacci numbers. So option A is correct. All right, so let us look at this. If n equals 0, return 0. If n equals to 1, return 1. That's okay, because the first number is, for n equals 0, the output should be 0.
Sir, I have a query in this. Actually, for tuples, we can initiate a comma b is equal to b comma a plus b. But first time I'm seeing that it is in normal also we can do for any integer a comma b.
In Python, you could do this. In Python, you could do this.
Okay, right. Not only for tuples, we can do for any number.
Yeah, you could do for any. Okay. So if n equals to 1, return 1, return. Otherwise, we should be returning f of n minus 2 plus f of n minus 1. This is correct, right? This is nothing but the recursive implementation of it, which basically means fib of 3 is nothing but fib of 1 plus fib of 2. Okay, which is correct. So even the second one is correct. All right.
No, sir. Here we are taking element from loop.
Yeah. We are just printing the element. Okay. What we are saying is, let's say we have fib of n. Okay. Fib of 5. Okay. Fib of 5.
Yes.
What is fib of 5? Fib of 5 is nothing but fib of 4 plus fib of 3, right? Okay.
Yes.
And then what is fib of 4? Fib of 4 is nothing but fib of 3 plus fib of 2. Okay.
But here it will be take first one, it will be take 0, then 1, 2.
It will check
3.
whether n equals 0 or not. It will not leave that. It will check whether this n equals 0 or not. Okay.
It will be recursive. That is fine, but it will be take from loop. It will be take 1, they take 1, 2, 3. That method it will be go.
Yeah, actually it goes from the top to bottom, right? That is, it starts from n, and then it goes for n minus 1, n minus 2, n minus 3, and so on. And so on, it will stop when n equals 0 or n equals to 1. Okay?
You didn't get it.
You didn't get it?
No, sir.
Okay. So let's say here we have defined fib of n. If n equals to 0, return 0. If n equals to 1, return 1. Okay. Else, what do we do? We return f of n minus 2 plus f of n minus 1. Okay.
Not as the Fibo.
Okay. Fibo. Fibo. What is f of 5?
Sir, here another code is missing for each I.
That is okay. That is just printing, right? That is just, we are just printing the, what that is doing is that is just
Here
first
we are
n.
calling the function. Here we are calling the function.
You're saying this, right? For n range of n.
Print Fibo of I.
So let me have this. Let me have 5, okay? Or let's say
Yes.
10. 8 maybe.
Not
okay.
5 is better.
5 then. Now let me run this. Now ideally it should be returning for me. It should return for me what? 0, 1, 1, 2,
0, 1, 1,
3,
2,
right?
3. Yes.
It has given me all that 0, 1,
Okay.
0, 1, 2, 3. Okay. It is not exactly
Date also,
0, 1. Let me run it again. Okay, yeah, now it works. 0, 1, 1, and then 2, 3. Okay. You could see here. Zero, 1, 2, 3. Okay. 0,
Every
1,
time it will
1.
be given different.
Yeah, that's because sometimes it doesn't.
Because it is printing for Fibo 0, Fibo 1. That's why we are getting like that. Because we are calling I from here. I0, Fibo 0 is called. Then Fibo 2 is called.
No. Now you are getting the correct one. Okay. Sometimes it doesn't work properly. Okay. Just like the portal, I do not know why. Okay. But you could see here we got it exactly 0, 1, 1, 2, 3. Okay. Let's say you do it for 7. Okay, you got 0, 1, 1, 2, 3, 5, 8. Okay. So this gives you exactly as required. Okay. And the reason it's working is we have here Fibo of 5 is going to be nothing but Fibo of 4 plus Fibo of 3. Okay. And then what is Fibo of 3? Fibo of 3 is nothing but Fibo of 2 plus
Fibo of 1.
Fibo of 1. Okay. Now we know that what is Fibo of. Let me write it this way. This is nothing but f of 4. I could write it as f of 3 plus f of 2, right? Correct? And then this f of 3 is nothing but f of 1 plus f of 2. Correct? Until now, am I correct?
Yes, sir.
Okay. So to compute this, it is going to compute this. Okay. I mean, our function is going to compute this. Okay. And now again to compute f of 3, it's going to ask for f of 2 plus f of 1. Okay. This part. Okay. Now to compute for this f of 2, it's going to ask for f of 1 plus f of 1. Okay. Now this f of 1 is already equals to 1. So I can just directly substitute it. Plus to compute f of 2, sorry. Here to compute f of 2, it's going to be
1 and 0.
1 and 0, yeah. Now to compute for this f of 2, it's going to ask for f of 1 plus f of 0. Okay. Now you just need to substitute this. Okay, except for this. Except for this, you can just substitute the remaining values. Now it's going to be f of 2 plus f of 1 is 1 plus this f of 1 is 1. Okay. Plus f of 0 is 0 plus 1 plus f of 1 is 1 plus f of 0 is 0. Okay. Which is going to be equal to. Now actually here itself I could write f of 1 as f of 2 as f of 1 plus f of 0. Okay. Now let me substitute this also. 1 plus 0 plus 1 plus 1 plus 0 plus 1 plus 1 plus 0. Am I right? 1 1 0 1 1 0. Yeah, 1 0 1 1 0 1 1 0. Yeah. What is this value? It's going to be 1 1 1 and then 1 1 5, right? Okay. Am I correct? Okay. Fine.
So,
all right. This is how this recursive part works. Okay.
Yes. Got it.
That's why the second option is also correct. Third option is Find range of n fib of n a comma b equals 0 comma 1. Find range of n yield a comma b equals to b comma a plus b. Then print f for I in f of. Okay, this is going to be the yield part. Okay, you know how the yield works, right? It actually runs for the entire one, but then it gives you iteratively the iterated part it gives you. Okay, this is just exactly similar to this return.
Sir, can you explain yield?
What does this yield does is it gives you the iterator of it. Define first n of n something. First n of n. Okay. For I in range of 10, I will yield I. Okay. Now let me run for I in first n of n. Let me not yield I. Let me give maybe I star I. Okay. Which is going to be I square, right? For I in first n of n, let me print I. Okay.
So what is yield means?
Yield actually it is actually similar to the return one. Okay. Except for whenever you encounter return, right, it's going to stop. Correct? It's going to end the function. But then whenever you encounter yield, okay, it's going to return it, but then still continue the program. I mean, still continue running. Okay. I'll just run this and then show you.
You want to say after in the definition actually after yield we can input some more loops, sir.
Can you repeat?
Yeah. You want to say in the definition, in the small definition, first definition actually after yield we can include some more while loops or for loops kind of thing.
You can use the output of the yield for loop and while loop, because yield itself is going to be the iterator one. Okay. Yield itself is going to be the iterator one. Okay, you could use it for iterating. So here you could see here for I in range of n. Okay, ideally instead of yield, if you have put I star a, return I star I, then it would have ended for in the first iteration itself. First iteration itself it would have returned 0 star 0, which is going to be 0. It would have returned and then stopped. But then since you have mentioned yield, okay, it's going to return 0 star 0, but then still continue for the next I values. Okay, that is for I equals to 1, 2, 3, and so on 9. So that is how we got this 0, 1, 4, 9, 16, 25, 64, and then 81. Okay. Similarly, in our function here, you could see here we are doing a comma b equals 0 comma 1, right? For I in range of 0 to n, you are doing a comma b comma a plus b, and then return a. Okay. The same thing you are doing here. Instead of like returning a, you are doing yield a. Okay. Because you are doing yield a, you need not call the function n times. Here you're calling the same function n times. Here you're just calling the function one time. For I in fib of n, you're just calling the function n time, one time. Okay, fib of n, because you're using a yield. Okay. Is this clear?
Sir?
Yeah. Why we are writing this for loop for I in FBI, and if we write print f inside the print set, I didn't get that function. Why we write that?
If you write print fib of n, will you get it? You're asking, that's the question.
Yeah, something. I didn't get this function properly.
Okay, so this you could actually find it in the in the 11th week, okay, functional programming part, okay, there you could look more into this, okay. Ideally, what yield does is it gives you a iterator one, okay. First time if we call it, it's going to give you the first yield one, which is going to be 0. Second time it's going to give you 1. Third time 1, fourth time 2, and so on, okay, and so on, like first n Fibonacci numbers, okay.
So sir, every time we write yield A, so it will directly go to the print statement, print I.
No. I mean, it won't go to print statement because you're doing for I in fib of n, you're printing I. You're printing whatever it was yielded. It did not print it. You're printing it. Okay.
Okay.
You're exclusively asking to print it. Okay. Here in the fib function, you're not printing it. The fib is just returning it. I mean, it is just yielding those points, yielding those values. Okay.
Okay, sir.
So yield can store the value.
Yield actually it's kind of like an iterator one, okay. Actually here it could be like iterating over
So
to entire range values.
here each time it is not returning because it is storing its value.
Correct. Actually you could consider it like it's returning a number of values. It's returning like n number of values you could consider, okay. And each time you loop
Yes,
through it.
That
Each time
yes,
you
that
loop
is
through
got it. But here it is storing.
Yeah.
Here it is storing the value because on your go through for I in Fibo, that is means that is already in store that Fibo series are already stored in Fibo of n.
Yeah, it is already the entire Fibonacci series. It's stored in the fib of n. Correct. That is why, like, you are looping through that fib of n and then printing I each time. Okay. Clear?
Yes, sir, clear.
Yeah.
Sir, can you show the code which you wrote on your IT?
This one for yield?
Yeah. Yes.
Here, instead of like yielding I have yielded I star I. So that is why it has computed square of the values. 0 square, 1 square, 2 square, 3 square, 4 square, and so on. And so on, like 9 square. Okay. Because I have given yield of, first n of 10.
So how does it store the value in a list or something?
No, it's not a list or something. It's actually iterator.
Similar like return.
Actually, you could actually type for this print type of.
Hello, sir.
Yeah.
Sir, actually, I have a doubt about what does exactly do the yield. The yield. Actually, I am not able to understand. Just we have said, but actually, I am not able to understand. So please, sir, say again.
What yield is going to do is it's going to like return. It's going to actually yield a list of. Not exact list. It's going to return like multiple values kind of thing. Okay, which you could be actually getting by looping through this first 10 values. Okay, whatever function output you are, right? By looping through that each time while you're like trying to print it or like access it, okay, you could get that particular value. In our particular case, for I in range of n, you are yielding I star I, which basically means you are yielding you're actually generating the first 0 square, 1 square, 2 square, and so 9 square you are generating. Okay, that's what you're trying to do. In that particular problem, you are yielding in the Fibonacci series. There you are yielding the first n Fibonacci numbers. Okay.
Oh.
Yeah.
Okay,
So you could look more of this yield in the 11th week. Okay, there it was explained even in detail. So, but for the end term, you'll not be getting any question from yield. So it's okay even if you do not understand it and so consider the following function f that accepts a positive integer as an argument n. So define f of n if n is greater than n star 0.5 is equals to int of n star 0.5, return 1 plus f of int of n star 0.5. And if n percentage 2 equals 0, not equal 0, return 1 plus f of 3 star n plus 1. Okay. Else return 1 plus f of n by 2, else if n is less than 1, n star 2, else return 0. Okay. This, if n star equals to 0.5 equals int of 0.5, conditional statement checks n is a square of a positive, any positive integer or not. That is correct, right?
Yes.
Because let's say n star 0.5 equals to int of n star 0.5. What that basically means is square root of n exists. I mean, square root of n is an integer. Only then it will be true, right? Okay. So this conditional statement, it checks whether this n is a square of a positive integer or not. That is true. Okay. So that is why question number 11 is true. Okay. Is that clear? Why it is correct?
Yes, sir.
What is the value of Fibo of?
I think
8,000. 10,000, right? Yeah. Fibo of 10,000. Okay. Let us actually run this. I mean, run in the sense like let's actually substitute the n values and then see what happens. Okay. 10,000 is greater than 1. That is correct. So now we have 10,000 star 0.5. 10,000 star 0.5 is nothing but 100, right?
1,000. Yes, 100.
Yeah, correct. So
yes,
it's going to return 1 plus f of int of n star 0.5, which is going to be 100.
100. Yes.
So it's going to return 1 plus f of 100. Okay. Now we need to compute for f of 100. So f of 100. Let me just write it here. Like here, initially we had 10,000. 10,000. This we found it to be 1 plus f of 100. Okay. Now we are computing for the f of 100. So now let us check here. 100 is greater than 1. That is correct. So
1 plus f of 10.
Yeah, it's going to be 1 plus f of
10. Yes, 1 plus f of 10.
Still, let me do it step by step. Okay. 100 star 0.5 is going to be 100 square root, which is going to be 10. Okay. And it is exactly equals to the int of 100 star 0.5. So it is going to be 1 plus f of 10. Okay. So now this is going to be equal to 1 plus f of 10. Okay. Which is nothing but 2 plus f of 10. Now we need to compute f of 10. Okay. So now again this 10 is greater than 1. That is correct. So we'll enter here. But square root of 10 is not an integer. So
yes,
this will not be correct. And if n percentage 10% 2 is
no.
not equal to 0. This
Yes.
is not correct because 10% is actually equal to 0, right? So
0, yes.
enter the elif block. Else return 1 plus f of int of n by 2. Okay, which is going to be 1 plus int of 10 by 2 is going to be 5. It's going to be 1 plus f of 5. Okay. So now this entire function is going to be 1 plus f of 10, which is going to be 2 plus 1 plus f of 5, 3 plus f of 5. Okay. Now we need
instead of int of f instead of int, if there is a no int, so it will be 0.
It would have been 5.0.
Could you done by this?
It would be 5.0.
Could you do this method?
I think we could still do it, yeah. But then, yeah, we could still do it. Okay.
Yes.
So now we are computing f of 5. Okay, 5 is greater than 1. Okay, so but 5 is not a actual square root. I mean, 5 square root is not a integer, so we will not enter the if block. And 5 remainder with respect to is not equal to 0. That is correct. So we will come here and we will return 1 plus f of 3 star n plus 1, which is going to be 3 star 5 plus 1, right? Correct?
16.
3, 5 is 15 plus 1, 16.
16.
Now it is going to be 1 plus f of 16. Okay? F of 5 is going to be 1 plus f of 16, which basically means it's going to be, now the entire value is going to be 4 plus f of 16. Okay? Now we know that f of 16 is a square root, perfect square root one. So it's going to return 1 plus f of 4. Okay? I mean 1 plus 16 star 0.5, which is going to be 4. 16 square root is 4. It's going to return 1 plus f of 4, and 4 is again a perfect square root. Okay, so it's going to return 1 plus f of 2. Okay, until now what do we have? We have here f of 16 is going to be 1 plus f of 4. Okay, and then f of 4 is going to be 1 plus f of 2. So it's going to be 6 plus f of, it's going to be 6 plus f of 2. Okay, clear? It's going to be 6 plus f of 2. Now we need to compute f of 2. Okay, now f of 2 is going to be 2 is greater than 1. That is correct. But 2 is not a perfect square root, and this is also not correct. Okay, so what we do is we come here and then we do 1 plus f of int of 2 by 2. Okay, 2 by 2 is going to be 1. So it's going to be 1 plus f of 1. Okay, it's going to be 7 plus f of 1. Okay. Now this f of 1 part, 1 is not greater than 1, 1 is not less than 1, so we'll return 0. Okay, so our answer is going to be 7 plus 0, which is going to be 7. Okay, so answer for this particular problem is going to be 7. Okay. Answer for question number 12 is going to be 7. Okay, this is clear?
Yes, sir. Clear.
So for this f of minus 8, we will still be doing the same procedure. Okay, you can repeat the same procedure, but then we will enter this block. Okay, because minus 8 is less than 1, right? So we'll go for like 1 plus f of minus 8 star 2, which is going to be 8 square 64. Okay, it's going to be now f of minus 8 is going to be equal to 1 plus f of 64. Okay, f of 64 is going to be equal to 1 plus f of 8.
Is it minus 64 or 64 only?
It's going to be 64.
1 plus f of 8.
Minus 8 whole square is going to be 64, right?
Ah, okay, okay.
Okay. So it's going to be 2 plus f of 8. Okay. Now for f of 8, 8 is not a perfect square root. So we'll go for, we'll come here. Okay. We'll come here. So it's going to be 1 plus f of 4.
1 plus f of 4.
It's going to be 1 plus f of 4, which means it's going to be 3 plus f of 4. Okay. Actually, we have seen here f of 4, right? F of 4 we have
Can
seen.
Hello, sir. Can you accept that type of question in time?
Yeah, you could expect it, but it won't be this much lengthy. Okay.
But that type of question very lengthy. It will take too much time.
Yeah, but as I told, right, you could expect these kind of questions, but not lengthy type, but smaller step.
Okay.
Okay.
Okay, sir.
So because we know f of 4 is equal to 2, okay, from here, Okay, we'll substitute that and then you could get f of minus 8 as 5. Okay, so this is going to be 5. Okay, how many questions left? 6 more, 7 more, I guess. Yeah. L is a non-empty list of distinct integers that is already been defined, which are the following recursive functions. Returns a sorted list in ascending order. Okay. Now we have here defined sort of L. L is not equal to empty list. Max index equals to L dot index of max of L. What does this gives? Can someone tell me? It gives the index of a maximum number, right?
Yes.
Am I correct? Now
Yes,
we are
sir.
looking for L of max index, comma L of minus 1 equals to L of minus 1, comma L of max index. Can someone tell me what we are doing in this step?
Last we are assigning the index of the max index in last element.
We are swapping the values of the max index and the minus form. That
Yes,
is the
last element.
Okay?
You are exchanging.
Yeah. So basically now L of minus 1 is going to be the maximum element. Okay. Clear?
Yes,
Yes,
sir.
sir.
Yeah. So now if we return L of minus 1 to sort of the remaining, this is not correct. It should have been the opposite.
Yes.
Okay, if you're doing this L of minus 1 to remaining and then sort of the remaining bit, it's going to give you the descending order, not the ascending order. Okay, that is where the first option is found.
But sir, we are not sorting the list. We are just interchanging the index.
Actually, you're not interchanging the index. You're interchanging the values at that particular index. See,
Yes,
L of max index is going to be L of minus 1.
But
and L of minus 1
remaining,
will be L of maximum.
remaining the hello sir, remaining index we don't know. Remaining index we don't know which.
Remaining it doesn't matter for us. See, each time all that matters for us is I want the maximum element to be at the end. Okay, I want the maximum element to be at the end, so that I will remove the maximum element and then sort the remaining elements. Okay, am I clear?
Oh, okay, that is got it. But if there is a L of 0 to minus 1, that is means it will be take first to until last until the last.
This line
That
number
is,
3, this line you were talking about?
No, last line. You talked L of, it will be correct if L of colon minus 1. If there, if yes, that means it will be counting first to until last.
No, it's counting the last element only. It's counting only last element. Minus 1 to remaining, right? Minus 1 is the last element, so it's going to include only the last element.
Last, that is means last to first.
Yeah, it's the cell of minus 1 to remaining. This in the return, right? This is going to be the last element, and this is going to be all the remaining elements except for the last element. Okay.
But here is a colon. L of minus 1 colon empty.
Yeah. L of minus 1 colon empty. It means we are returning a list containing only the last element. Okay, let me show you. Let me just show you that part. So, for example, I have L equals to 1, 2, 3, 5. Okay. Let me print L of minus 1 to remaining, and then print starting until the minus 1. Okay. Could see here I got 5 and then 1, 2, 3. Okay. Okay.
Okay. Got it. Yes.
Now that we have here, we know we have actually interchanged the values of the max index and the minus 1, right? So that the last element is going to be the maximum element. Now we are having the maximum element first and then the remaining elements later. Okay. This is nothing but not the ascending order, it's descending order. Okay. It should happen opposite. It should happen sort of L colon to -1 plus of L -1 colon. Okay. So that is why option 2 is correct. Okay. Is this clear?
Yes, sir, clear.
If it has been the minimum one, right? If it has been minimum one, I mean, by minimum, I mean like you do it this way, you find the minimum index, that is the minimum value index, okay? And then you swap it with respect to L of 0, okay? You swap it with respect to L of 0, which basically means now L of 0 is going to be the minimum element position, okay? So then this is going to be correct, okay? Am I clear on this?
Yes.
Okay. This is not correct. The fourth option is not correct because we are having the minimum element at the end. The minimum element should be at the starting of the list, right? So the fourth option is not correct. Okay. Okay. We move on to the next one. Define pho of k. Try k equals to p. If k equals to p, raise value error. Okay. Except value error, except name error, except syntax error. Okay. What is the function pho of 8 will return? Okay. We have mentioned pho of k, right? Try k equals to p we have mentioned. But until now we do not know what the value of p is. Okay. So it's going to raise a name error. It doesn't know what this p is, so it's going to raise a name error. Okay. Clear?
And k is 10, right? How can we keep 10 as a variable? Can we keep? No, right.
What?
Foo k is 10, right? Here try 10 equals to p.
Yeah,
That
10
means,
equals to p, and we don't know what the value of p is.
10 is not a variable, right? 10 equal to p. That's not double equals to. It's assigning, right? 10 equal to p.
10 is not a variable, correct, but then k is a variable which has the value of 10. Okay.
Okay, now here I'm trying, okay, k equal to p, 10 equal to p. How can we assign? I'm asking. It's not possible, right?
Actually, no.
It is possible if it is p equal to k.
Okay. You're just confusing.
variable,
You're
we
getting
can assign
confused.
a value
Okay.
to a variable.
K is just a variable. K is
Yeah.
just a variable whose
K is
value
But
is
here
equal
we
to
are
10.
proceeding with 10, right? Let's take
We are
10.
proceeding.
Okay.
Yeah, we are proceeding with 10. We are proceeding with 10. But still, what is that means is k is a variable whose value is 10. That's it. Okay. This k value at any moment of time, it could be changed to any other value. Okay. It doesn't mean that we are assigning 10 value to p. Okay. I mean, we are making 10 equals to p now. We are just making k equals to some p value. Let's say if p is defined. If p is defined, then it would have run exactly correctly. Okay. Am I right?
P is defined also. I'm not understanding. Here 4, 10. So 10 equal to some p, how can I assign?
You.
Here it's written, given that question, what function 4, 10 will return. So I have to proceed with 10 only, right? Not
Yeah,
h.
you have to proceed with 10. I'm not denying that. Okay. Yes, like this.
For the given question only, I am asking. The question is, what will 4, 10 will return? So I have to proceed with 10, 4, 10 straight away.
Yeah, you have to proceed with 10, correct. You have to proceed with 10, but then let's say k equals to, I mentioned 100, okay? Print k. Okay. So print O of 10. Okay. Now what do you think is going to happen? For this?
I don't know. Because 10 equal to 100, we cannot assign, right?
See, do not have 10 10 is not equal to 100. You are just making k as 100. K is a variable whose value is 10. That's it. K is a variable whose value is 10. Okay. Let me just print this. It's going to print 100. Okay. I mean, it has given me none because we are not returning any.
No, in these functions, what I understood is print foo of 10 means I have to keep 10 in place of k and I have to proceed the function. That's what I understood.
You do not have to always keep 10 in place of, 10 in place of k. Initially, you just need to assume that k equals to 10. Okay. That's it. Okay. Here, it does not throw an error. Let's say if you do 10 equals to 100, it's going to throw an error. Okay.
Yes.
Okay, it's going to throw an error. But then if you do k equals to 100, it won't throw an error because it's not always substituting k as 10. Okay, it is just k is a parameter whose value is 10 for this particular instance. That's it. Okay.
Sir, the value is getting updated by 100, right?
Yeah, the value is getting updated to 100. Okay. Clear on this?
Okay. So whatever we write in foo, it will take 100 only.
Yeah. At the end, it's going to be equal to 100 because it doesn't matter what the value of k is. You are equating to 100, right? Initially, k is going to be what you mentioned, whatever we give. But then after line number 2, it's going to be 100.
Okay, fine. Understood.
Here, the error is happening not because we are equating 10 to p, 10 equals to p. It's because we don't know what p is. That is why we are getting error. Okay.
Okay.
Can we expect this type of questions?
Yeah, the try except one you could expect. One question.
Yeah, one question. How many marks?
Around 2 to 3 marks. Okay, now we'll come to this oops one. Class test define init self dot variable equals to old self dot change of self dot variable. Okay, and then you are doing change of self comma where equals to new object equals to test print object dot variable. Okay, what's going to happen? Can someone tell me?
Old is printed.
Object
New
dot variable
variable.
will print self dot variable value old.
It's going to print new, right?
Yes.
Old.
Old. How many is printed?
No, sir. Variable and VAR is different. So
Okay. Yeah, sorry.
self dot variable
correct.
and that's
Ha. Yeah. Correct. They mentioned just var equals to new, but the variable is going to be same. Yeah. So object dot variable is still going to be old. Correct. Okay.
And you please explain the fourth line.
This line.
Yes.
Self dot change of self dot variable. This one.
Yes.
Here we are just passing the variable value. That is old value. We are passing it. Okay. Here it's just going to. That is going to be as copied. Okay.
The self dot change, is it anything change related to something here?
Self dot change is a function. That's it. Self dot change is a function where we define change of self comma where we are, right? So whenever you call for the self dot change
Okay.
you're going to call this function. Okay.
Okay.
So it means when we call the function self dot change, then only new will be printed.
Actually, new won't be printed, right? We are just assigning var to new. That's it.
Okay.
New won't be printed. Or if you actually change it to self dot variable equals to new, then obj dot variable would have been new. Okay. But right now old one will be printed. Okay.
Okay, sir.
Then now let's go for this. Print. This is a class message. Print init self. This is object message. This is class message 2. Okay. It's going to be the output of this.
Last one.
So this one I didn't get, sir.
Me too.
So this is like I don't know what code is doing first and then what is it? Like,
okay.
So is second option of correct?
What?
second option correct, sir? Is second option correct?
No.
We can just run this and then check, right?
Second only correct.
Okay, so here let me just write the program for this and then show you. Okay, so print constructor and then is this the one? It's approximately the same, right?
Yeah, okay. A equal to test, B equal to test.
Yeah.
Yes.
You'll not be asking this much tricky questions there, but okay, I did not call for this. I did not create an object. Okay. Could see here it has given me class 1, class 2, and then constructor. So whenever it is reading this class itself, even though you haven't created an object, right, it has still given me initially class 1, class 2. Okay. So while reading this,
Class 2 came first and constructor came at the end.
Yeah, I was trying to explain that, right? Because even if you haven't created any object, right, it has still printed for me class 1, class 2. Okay.
Yes.
So it doesn't matter whatever messages you're printing, like in the class, right? That's going to get executed directly. Okay. Clear?
So this is class variable.
It's not kind of like variable kind of thing because we are not storing anything. It is just a statement of the class. Yeah, that you could think. Okay. For example, here, let me do this. Define or print.
So try with yesterday's program. It is
know?
much easier.
What?
So yesterday's program you have explained about this, right? That is more suitable, I think.
No, let's finish this first.
Like here, you could write a function, define prime of something, some random function I mentioned. Okay. Takes an boolean, and then what it does is it just prints in. Okay. Now let me go for this. Could see here, right? It has given me 10. Okay, class 1, 10, class 2. So what this basically means is this is getting executed always. Whichever functions, like class functions, okay, which you're called, or class whichever methods you're called, even this print one, okay, that's going to get executed even though you haven't created an object. Okay, like let's say I remove this line one, which means I didn't create an object at all. It has still executed this for me, class 1, 10, and then class 2. Okay, so that is the reason why we got this as like this.
No,
is
here
class
I'm
1.
unable to understand. 10 came, but why constructor not came?
Because you didn't create an object, right? You didn't create an object up until that point. Only once you have created an object, then the constructor will get executed. Okay.
So,
whenever you create an object, only then the constructor function will be called, right? Okay.
So, sir, what I understood is like, can I, like, if I'm wrong, can you please correct me? Because when we enter the code, so we first print this is class message 1. This will always be printed.
Yeah.
And then when we are getting the inside this def function, so we are first printing this is class message 2 because this is outside the function, and then we print this is object message.
No, it's not like that. See, I just mentioned that even though you haven't created any object,
yes,
even though you haven't created any object, for example, here I did not create any object, okay? I just defined class, that's it.
Yes.
I just written code for class, but still I got this message, right? Class 1, class 2, and then 10, okay?
Yes.
Even though you haven't created an object, this is class message 1, this is class message 2 will get executed.
Yes.
Okay? So that is the reason why we will be getting it as like this is class message 1 and this is class message 2. This is object message and this is object message.
Because this is because A and B. If it was only A, then it would print just once. This is
this is object message. Yeah. Okay. So whatever methods.
Why it's not came 2 times 3 sentences? Because we gave A and B 2 times, right?
Yeah. That's why you got this object message 2 times.
No, why not 6 times? Message 1, message 2, and the message. Message 1, message 2, message for each test.
This is going to just get called only once. No matter how many times you call this, you call this, you create an object, right? This print messages will not be getting called. This actually belongs to class.
So to print this is object message, we need to create object, otherwise it will not be printed.
Yeah.
Okay. And the other 2 will be printed anyways.
Yeah.
Okay.
So we move on to the next question, 18th one. Open a text in the write mode. Write hello world, how are you today? F.close. Open hello.text dot read. Data equals step dot read lines. For lines in data, words equals line dot split. Print words. F.close. Okay. It's going to just give you line dot split.
Error. No, sir. Third option.
It's going to be third option. Why will it give you error? It has only one line, which is going to be hello world, how are you today? And then it's just going to split it. Okay, it's going to split. Whenever you do not mention anything, that means it's going to split by space by default. So it's going to give you hello world, how are you today? Okay. It's going to give you a list of that words. Okay. So line number,
as it is a list, single quotes are there as it is a list. Huh?
Can you repeat? Single quotes?
Why single quotes are there? Because is it a list? That's the reason.
No, it's not like that. See, it is just a way it gets printed. Okay. Single quotes, double quotes, it's still a string. Okay, it's still the same string.
No, I didn't understand why what line dot split does.
Why it got the single quotes or double quotes? That's what you're asking, right? What?
Hello. Whenever it is whenever that read lines is executed, it is moving to a list. Data is a list, and whenever it is going into that list, each list within that list, each word is separated. Each word will be a separate word and will be quoted with these quotes. That's why it is getting printed as hello with quotes.
We just have one line and then that itself got splitted, and because of that we are getting it as like hello world, how are you today? Okay. Clear?
Why not only hello kind of thing? Because
why not only? Why the quotes are coming? The quote.
Because it's a string, right? Because hello is a string. Hello is a string.
Why not fourth option?
What? Why not?
Fourth option, only hello.
Why not fourth option?
Input is not that.
Words is a list. Words is a list. Lines dot split, it will give you a list. You are printing a list. When you are printing a list, it will be in this manner. Why will it be as a hello? If you are printing words of 0, then it would have been hello.
That's what I thought, sir. Only So S of 0 would be printing. The remaining would not be printing at all.
Yeah. I will move on to this line number, question number 19. L equals to empty list for I in range of 10. If 5% is 2 equals 0, L dot append I, else L dot append odd. Okay. Yeah. This is why you'll append I value if I is odd. Otherwise, you'll append it as like odd. Okay. You'll append I value if it is even. Otherwise, you'll append it as like odd. Okay. So ideally, it should have.
Yeah, all the four seems to be good fit kind of things. I don't know why someone is playing, failing in this.
I'm sorry, can you repeat?
I thought all the four options given are correct kind of thing. Means fit for the.
Okay. So we'll check. If I percentage 2 equals 0, else odd. Okay. This colon should not be there. Okay. That colon should not be there in the first option. That is why it's wrong. Okay.
Hello,
Yeah.
sir.
Yeah.
So actually, in the previous questions, I have thought that just one line has passed Nasser. So how this is splitted in the different word, sir? Can you explain it again, sir, please? Actually,
This is called as a list comprehension, which was explained in the yesterday's session.
So he's
Yes,
asking the previous question.
yes, sir. About previous
Because it is a
question,
read
sir.
line. Read lines because it is a read line.
Yeah, line of
Read.
Read lines
Line.
means, sir. Hello, sir. Here only one line has passed, na, sir.
No. It's a lines, not a line.
Read lines, yeah. Read lines
It's
is
not a
going to
line.
give you the list of lines, okay? It's going to give you the list of lines that are there in the file, okay? But
It's
right
a
now,
list of lines, but sir, here is only one line is available now.
yeah, but it's going to be list of only single element. It's going to be a list of only single element.
Yeah, it's only single element, but here is the line is splitted means only one line is available. So
yeah, that
I will
that
get
line
only
alone,
one line as a list. But here is a mention you. Yeah, sir. Yeah.
yeah,
Hello.
that line alone it gets splitted. That one line alone it gets splitted into it gets splitted based on space. So that will become a list.
So this code will return the same output if that is on a read line, f dot read line.
No.
Read lines means, sir, only one line.
Yeah. If it has been like data equals chef dot read line, right?
Yes.
Then data will be equals to hello world, how are you today?
Yeah.
It's going to be data is going to be string.
Oh, I got it, sir. Oh, sorry. Actually, just I am actually studying about that. I have a list, but here I have a line means line only. Okay, sir, I got it.
Okay.
So
Data
we'll
is
get
a
the same
line.
output if that is a read line.
No,
Other
if
than
it has
read
been
lines.
read line, if it has been read line, then data is going to be a string, okay? Then data is going to be a string.
Okay.
Then when you're doing for line in data,
Yes.
okay, then line is going to be character.
Okay.
Yes, sir.
Okay.
Got it, sir. Okay, sir.
So output will be second option.
Thank you, sir.
Then the output will be, you can actually execute and then check it, but the output will be something like a list. Okay, a list. Print words is going to be a list, but then each time the words is going to contain only one character. So H is going to be the first list, E is going to be second list, L, O, and then space W and so on. Okay, you can just execute it. Okay, coming to this 19th question, this here the colon should not be there. That's the first option is wrong. Second option is all right. Odd if 5% is to not equal 0, else it's just a reverse of it. So this is correct. L dot append I does not work here. Okay. L dot append I, it's wrong syntax. So option number 4 is wrong. Okay. Coming to the last question.
Son,
yeah.
Why C is correct?
It is odd if 5% is to not equal 0, right?
Okay, not equals to. Okay.
Yeah, else that's why I told it's just like we just like wrote it in the reverse order. That's it. Okay. 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6, 7. Okay. List of map of lambda of n and then n comma n, and then we have this m star n. Okay. Okay.
Are these functions important for the exam point of view?
This one, no. From the exam point of view, the lambdas and the maps, it's not going to be important. But the list comprehension is going to be important. Okay.
Zip, enumerate, generator, all these.
No, they too are not going to be important.
Okay, thank you.
So we have here a comma b. Okay. What it's going to do is it's going to map from one value of a to other value of b. Okay, the corresponding value of b. And then what this lambda does is it's going to multiply these elements. I mean, whatever elements we have, 10, 1, and then 22, 33. Okay. So the output is going to be equals to 10, 1, and then the overall value you're converting it to a list. Okay. So it's going to be 10, 1, which is going to 10 into 1, 10, 20 into 2, 40, 90, 60, and then 250. Okay. So it's going to be option number 2. Okay.
So the length of A and B shouldn't be equal for this one?
It need not be equal.
Sir, why can't be first option?
Why can't be?
First option.
No, because here we do not have any elements to multiply, right?
Okay, no. Okay.
Okay. Yeah. Okay, so that's it. I mean, that's the end of mock.
Sir, I have a doubt in 17th question.
Which question?
17th.
Okay.
Sir, I didn't get this.
You didn't get this.
Yes.
So whenever we are adding this class
A
shift,
equals to test and B equals to test, what it is doing.
A equals to test and B equals to test, what does it mean? That's your question?
Yes.
Here A, we are creating an object, and B, we are creating an object. Whenever you're creating an object, then this constructor function will be called. This init function will be called. Okay. So similarly for B, B also you are creating an object. So this constructor will be called. Okay. Whenever you are reading this, right, whatever class methods are there and whatever class functions are there, so those will be called. So this print function will be called, and here also this print method will be called. Okay, first. That's how you got this. This is class message 1 and this is class message 2. After that, because you created an object, this constructor got called. Okay. And similarly for B equals to test also, again this constructor will be getting called. That is the reason why you got this as like this is object message and this is object message. Okay.
So we have called 2 times, like A and B. So it's not like yes.
What?
Nothing. I got
it. Yeah,
it.
we got A and B 2 times. That is why you got this object message 2 times.
Yes.
Okay. Any other questions?
Sir, if we only define the class, it will automatically call the class, sir. I couldn't understand that point.
Can I repeat? If it is only
if we define a class, will it automatically show the output of the class inside?
Yeah. Suppose let's say you have this. Whatever methods you call, right, and then whatever functions you call in that class, then that's going to be getting called. That's going to get executed. Okay. So here this print method got executed and this print method got executed first. Okay.
Hello,
Okay,
sir. Yes, sir. Hello, sir.
Yeah.
I actually have a doubt in the practice questions of week 9. The first question.
Practice assignment, right?
Yes, first question. Sir, actually, I have a doubt in this question that what is the difference between? No, sir, it's not. I think it's a credit assignment, sir. Sorry, actually, just I forgotten. Montage है क्या ये?
Yeah.
एक मिनट sir, just actually I think it will be the week 9. Sir, can I check? Wait, sir, sir.
Yeah. Okay.
Hello, sir.
Just a minute, sir.
Yes.
Sir, when we talk about lead comprehension, there any kind of rules or regulation can in my, so by that I can in my mind.
You can just follow the yesterday session. Have you attended yesterday session?
Okay.
So
Yes, sir, I got it, sir. Actually, it's a week 10 question, sir.
Yeah, okay. So I'll answer Shivan Dikshit question. So in the yesterday session, there we discussed about this list comprehension. Whatever that was discussed there, that alone is going to be sufficient.
Okay, sir. Thank
you. Okay. Week 10, which question?
The first one, sir, practice assignment. Sir, actually, the thought is what is the difference between the class attribute and the object attribute? I mean, here is a mention that the name imply ID and the salary is the class attribute, but actually I think it will be the object attribute, no sir. So actually I have
Whenever you have something like self right attached to it, then that's going to be object attribute. Okay.
Yes, sir. But in these questions mentioned, the answer is mentioned that the name imply ID and the salary is the class imply. Yes, sir.
What?
The answer is mentioned that name imply ID and the salary.
Yeah. So here, whatever attributes we have for this class, right? The same thing that was, I mean, for object, the same thing was considered for the attributes of class 2. So that is the reason we have this name, employee ID, and salary. These are the class methods. Okay. Methods. So that is the reason, like, why they were not set. They're not attributes. Okay. So that is why increment salary print info, that is not correct. Okay.
Actually, sir, I'm not able to understand. Just in the lecture has mentioned that after class imply function defined, the anything written like a count or anything, that will be the class attribute. But here is mentioned that the name implied and the salary will be the attribute. So that's my question, sir. Or I didn't get it.
Ideally, if it has been like something like none option is there, right? Then none would have been correct. Okay. But since the none option is not there, so like you'd be selecting the employee name and salary. But ideally, these are the object attributes. Correct.
Okay, sir.
So
Thank you.
Yeah.
So if we create an object here, and which part of the function will be executed? Everything, all the three functions?
No, all the three functions will be getting executed. Only this constructor will be getting executed. When you just create an object, right? Only the constructor will get executed.
Yes.
That's it. Okay, the other ones you need to explicitly call them. Okay.
Okay.
Yeah. Any other questions?
No, sir.
Yeah.
So give some tips for exam.
Okay. Tips like go through this list comprehension one, okay, and then try to look at the code step by step, okay. Overall you should be understanding what is happening, okay. If possible you should be understanding what is happening across code. For example, like in the previous where we have seen for SQ or T and all.
Yes.
Okay, there you should be, I mean, along with you reading the lines of code, right? You should be understanding overall what it was trying to do. Okay, because they are asking you just that, right? Like whether the function is trying to find the maximum element or minimum element. Okay, and then try to find the small differences from. Okay, that is the greater than or equals to and greater than 1. Try to look at those small things. Okay, because those small things will change the answer. Okay.
Okay.
I mean, give attention to those details.
Okay.
So, and as
So
long
what
as
is the weightage of week 10?
Huh?
What is the weightage of week 10?
Weightage of week 10, this one,
Yes.
it's going to be somewhere around 10%, 10 to 15%, 10 to 15%.
Okay, 2%.
Yeah. 2 to 3 questions, yeah.
Okay.
Okay. Any other questions?
Sir, is it enough for getting a sum of around 60 to 70 if we see the graded and practice assignments of all the weeks?
Should not just be seeing it, it should be understanding it.
Yes.
Then yes.
Okay, if you understand that, so.
And actually look at the mock question also.
Okay.
That is good.
Okay.
Are the practice assignments are NHL? I mean, grade are not that much key. I need to say.
Once you look at the concepts, okay, once you're like very versed with the concepts, and then you are able to understand each and every problem of the practice and grade assignment.
True.
And I meant like understand, you should be understanding why a particular option is correct and why other option is wrong. Both you should be knowing, okay? If you're able to know that, then you'll be able to do well in the internal exam. Okay. So, and one other tip is like when you think of like for example, suppose here they'll ask me to write a function, right?
Yes.
Suppose let's say you think that this first option is correct, okay? Do not directly select that first option and then move away. Okay.
Okay.
Look at the other options too, see what's the difference. Okay.
Okay.
Then actually some parts which you would have missed, that might be mentioned here. Okay.
Okay.
So even though you think like some particular option is correct here, still you look at the other options and then see why they are wrong.
Multi-selected are tricky. Multiple choice is okay. Multiple selected MSc questions are difficult.
Yeah. So if you are going for this MSQ questions, make sure you select those options which are like perfectly sure, okay? Because even if you select one wrong option, you're going to get
That is okay, but how to judge, how to eliminate, is there anything in MSQ?
like here also you should be just looking for the difference between those two. Like for example, here let's say the first two are kind of like straightforward. If you're not entirely sure of this third one, you can just leave it out. Okay, but ideally, if you know the yield function, you could see that the first and last are like almost similar. Okay, all you're doing is instead of returning, you're just yielding A. Okay, and then instead of doing this for I in range of n print fib of I, you're doing for I in fib of n print I.
Okay.
Look for the similarities and then look for the differences. Then you'll be able to be better judge. Okay. Yeah. Any other questions? No. Okay. Please be patient. Okay. Patient in sense like be attentive. Do not get tensed. Because one small, if you're not too attentive, even though you might know the concepts, you'll be making errors. That you might be aware of it by quiz one also. When compared to programming, looking at the code and then answering it, that's comparatively easy, but still you need to be paying attention and then answering it. Look for the differences between two options. Okay. Then you'll be able to better judge. Yeah. So that's it from my end. Okay. Hope I have covered all the concepts. Yeah, I have covered all the concepts that are required. So if there are no other questions, then we can end the session, and all the best for your exam.
Thank you.
Thank you, sir.
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 Hello.